So it has apparently been 4 years since I started posting 3D and GameMaker videos again, and all in all, I don't know how to feel about that, but to celebrate the occasion, there is a particular subject which I covered a long time ago, back in the old days as it were. I think this was back in like 2018. And some time has passed since then, and there's been a few GameMaker updates, and it's actually gotten progressively easier and easier to do what was in that video. So let's once again dive into how you might import a .obj file into GameMaker. So if you've done anything with 3D ever, you probably have heard of OBJ files. They are definitely one of the most common, if not the most common, 3D object file format. Other formats do exist, FBX, GLTF, Collada. Those are considerably more complicated, and I don't really feel like getting into them right now. But today we're going to write about 100 lines of code, and we're going to import this 3D treasure chest model into GameMaker, have it render, all that fun stuff. This is one of several common 3D test files that I like to use in GameMaker. I believe this is the Xenoblade Chronicles chest from Breath of the Wild. Just in case you think this looks vaguely familiar and are having a hard time placing it. So, before I begin, this is what I'm going to start with in GameMaker. I just have a 3D test world. We've got a bit of a checkered floor on the ground. And we've got a 3D camera, first-person camera, all that. Before I get started, I would probably slot this into my 3D and GameMaker playlist, after vertex buffers and after the explanation of texture coordinates, but before I get to 3D lighting. I do have a basic 3D lighting shader in this project that I'll be using just so that the world looks a little bit less flat, but I'm not going to be talking about it. You don't have to know how it works. I would also like to say that I'm not going to be talking about everything that you can do when it comes to dealing with .obj files. One of the things that honestly makes .obj kind of a pain to deal with is that a lot of different 3D programs have different unofficial variations on the spec that they might or might not use. And so I'm not going to be spending any time in this video talking about things like unofficial extensions for vertex color. I'm just going to go with the description of the file that you might find on a site such as Wikipedia. I'm also not going to deal with the material file that you might often see alongside a .obj file. You totally can deal with this. You totally can parse a material file to split an object into different material types or deal with different texture images or that kind of thing. But I'd like for this video to not be an hour long, so that's going to have to be a story for some other day. Lastly, and this is a bit of a revelation that most people have eventually, .obj files actually aren't really all that great for dealing with in games because they are plain text. They are stored in plain text, and that makes them very slow to parse, among other problems. So most of the time what you want to do in games is convert your OBJ files to some kind of binary format, some kind of raw vertex buffer format, and load that into your game, because that can be very fast indeed. But if you've never done this before, I still recommend writing an OBJ parser at least once, because I found that in my god knows how many years of doing 3D in GameMaker, I found that a lot of people don't really realize or internalize what goes into drawing something on the screen until they've had to deal with loading vertex data from a file. So I still recommend doing it at least once, even if it doesn't become something that you need to do, perhaps, every day. Let's see. I can close Blender now, can't I? Yeah, let's get rid of that. The first thing I'd like to do is I would like to open this project in Explorer. I would like to go and actually, let's copy in Xenoblade chest.obj into the GameMaker included files. I'm also going to go and just drag in the main texture for this thing, so the albedo texture into GameMaker, and we can call this SPR_Xenoblade or something. I'm also going to store this on a separate texture page. The separate texture page button is a magic checkbox that you can check to make sure that you don't have random problems with UV coordinates in 3D and GameMaker. The material file that goes with the OBJ would have a reference to the texture file or texture files that the object uses, but since, as I said, I'm not going to be dealing with the MTL file today, that's not really relevant. You might notice that there are all sorts of other texture maps that might go with this, such as a normal map, I believe that's an emissive texture. That might be a specular texture, actually. I have made videos on things like normal mapping and specular mapping in the past. I will have links on screen if you want to go and visit those, but once again, beyond the scope of this video. So the first thing I think I need to do is, let's create ourselves a little script. I can call this import obj. That's going to be our obj importing function. I'm going to pass 2 arguments into this import obj function. That is going to be the file name and the vertex format. And so when we call this in, for example, the create event of the camera, or in the create event of whatever the first object that you load in the game is, or the object that handles all the stuff rather, we can say something like chest equals import obj. The file name is going to be Xenoblade chest.obj. The vertex format is going to be our ordinary 36-byte vertex format, 3D position, 3D normal, 2D texture coordinate, and a 4D color vector. You know what? This is going to bother me, but I'm just going to change the name of Xenoblade chest to just chest, because 1, I don't want to have to deal with remembering capitalization, and 2, I don't want to have to deal with remembering if there's spaces in the name or not. So that's going to be our import obj function. So now that I'm in here, I'm going to need to read the contents of this file. So as I said, over the years as GameMaker has updated, it has gotten incrementally easier and easier to do this. If you've seen obj import scripts on the internet before, you've probably seen a few different variations of the same thing. You might have seen in the past someone use the file text open read and related functions to read text from a file line by line. You can still do that. I don't really like doing that. I would rather use the various buffer functions, such as buffer load, to read the contents of the entire file into memory at once. And then, because the obj file is, like I said, plain text, we can just read out the contents of that buffer as a plain text string. Delete the buffer when we're done, because we don't need it anymore after we've gotten the content string out. And then you can use the string split function, which is again a rather recent addition, to take the content string, which contains the entire content of the file, and then split it into an array separated by the new line character. And now we have each individual line of the file in this array, and we can loop over it, do whatever we want with it, import our obj. Everyone's happy. So this would probably be a good time to actually discuss what it looks like inside one of these things. So if I were to just open up, no, notepad, no, update, go away. If I were to just open up this .obj file in a text editor, you would see there's a couple different plain text looking things in it. So there's some comments at the top. This line's beginning with a £, or if you're a nerd who likes to say words out loud, an octothorpe. These are comments. These are for the benefit of the reader. It just tells you that this file was generated in Blender, in case that was something you wanted to know. We can see a few different lines. Most of them begin with the letter V. I'm going to zoom in on this a little bit. Most of them begin with the letter V, followed by 3 numbers. That denotes a vertex position in 3D space. If you scroll down, you can see some other things. VT stands for vertex texture. That's a 2D texture coordinate. If you scroll further down, you can see VN, that stands for vertex normal, which is used in lighting calculations. And if you scroll all the way down to the bottom, you can see some lines that begin with F. These are individual faces or triangles or polygons. They don't necessarily have to be triangles. This tells you how to put together vertex positions, normals, and texture coordinates into an actual 3D mesh. And there are some other things that you might find in an OBJ file. If you see all the way at the top, there is a line relating to a material file. There is a line beginning with an O for an object group. I'm not going to deal with these. I'm going to pretend they don't exist. If you're writing a really fancy OBJ parser, you can deal with these, but for the sake of simplicity, I'm not going to. There's also a few other things that you can find in an OBJ file sometimes that are maybe a little less common, such as like smooth shading groups and that kind of thing. I'm just going to deal with the basic vertex attributes that you might find in these files. So firstly, I suppose it'll make sense to create a vertex buffer, and then initialize the vertex buffer for writing to, using the vertex format that we passed into this import obj function as an argument. Way down at the bottom when we're finished, we can vertex end. If you'd like to, you can vertex freeze. You can make the vertex buffer read-only and slightly faster to draw. And then when you're finished with all that, you can return the vertex buffer, and you can draw it and do whatever else you want with it, like a regular vertex buffer. I'm also going to need let's say 3 arrays, one for positions, one for texture coordinates, and one for normals. So remember, if I were to open this up, the main bulk of a .obj file is just a big old list of 3D positions, 3D normals, and 2D texture coordinates. When I read those out, I'm going to insert them into these positions, texture coordinates, and normals array. That was a hard sentence to say. And then when we're done, like I said, you can assemble those into 3D geometries. So first, let's start by looping over the lines list. So we can do an ordinary for loop here. For I equals 0, I is less than array length, I plus plus. As always, you can optimize this for loop however you want. I'm not going to get into that debate today. Firstly, I'm going to say this line is equal to the lines array index I, so that is going to loop over the lines array, and that's going to just give us every string in the lines array one by one. .obj files can contain first and foremost empty lines, so this is legal. You can have as many empty lines as you want in an obj file. There's not really any reason to, but it's allowed, so it would probably be a good idea to say if this line equals an empty string, to just continue. Continue will skip the rest of the for loop. Apparently the continue statement is rather controversial, I guess because it looks a little bit like a goto in some, if you squint hard enough, but I think continue is fine. If this line is an empty string, just don't do anything else and continue to the next iteration of the loop. Next, so each of these lines is going to be a letter, or I guess a couple of letters at the beginning followed by some numbers, separated by spaces, so we can break out our old friend string split again, and I'm going to say var tokens equals string split. This line, we can have a space character as our delimiter this time rather than a new line character. String split is so nice. It's my favorite new addition to GameMaker. That's probably not true, but I do like string split. Anyway, this is going to split this line into individual tokens or individual words, and that will allow us to look at the first item in the tokens array, and we can use a switch statement there, and we can do different things. We can do different things. I need the parentheses. I need the colon in the right place based on what the first item in the tokens array is, what the first token is. So v is going to be, as I said, a vertex position. So I might say var vx is going to be tokens index 1, vy equals tokens index 2, vz equals tokens index 3 for the x, y, and z coordinates of each vertex. These are still going to be strings. These are not actually going to be numbers. These are going to be just strings containing a representation of a number. So we're going to want to tell GameMaker that this should be a real number using the real function, and that will parse the number, turn it into an actual number data type. And then I'm going to array push onto the positions array a vector, which is going to be x can be vx, y can be vy, z can be vz. So we're going to push just a little struct containing an xyz position onto the positions array. This is yet another one of those things that you might have seen done differently in the past, because a lot of OBJ import scripts for GameMaker that are floating around the internet were written long before the advent of structs in GameMaker. But since we have JavaScript-like structs, JavaScript-like objects now, we might as well use them to make our life a little bit easier. That's going to be our vertex positions. We could do something similar for vertex normals. In fact, I'm just going to do the same thing. Let's say var nx, ny, nz for our normal vectors. We can push a struct containing those values onto the normals array, and texture coordinates are going to be similar. But these are just a 2D vector, so instead of saying nx, ny, nz, it's going to be, let's call it tx, ty. You could call it u or v if you prefer. No z coordinate there. What was it? Texcoords. And just like that, we're about halfway there in terms of both like the amount of work we have to do and the line count, because what did I say? This is going to be about 100 lines, and we're about 50 lines in now. So if I were to run the game now, nothing's going to happen. We're not actually writing any data into our vertex buffer, and when we try to call vertex freeze on an empty vertex buffer, we get this error, so try to avoid doing that. I appreciate that the game didn't crash outright, though. It just didn't, like, do anything. We still need to actually feed this data into the vertex buffer, and to do that, we can look at the face attributes, and we can use the face attributes to start, as I said, assembling vertex, texture coordinate, and normal data into an actual triangle mesh, into an actual vertex buffer. So face attributes are a little bit more complicated. So in this line here, for example, you see a set of 3 numbers separated by slashes, and then there's going to be 3 of those. So each of these groups of 3 numbers represent each vertex of a triangle, and within each vertex itself, we have the 3 numbers which correspond to a position, a texture coordinate, and a normal. And these numbers are the indices of the positions, textures, or normals that were defined earlier in the file. There's one caveat to that, which is that these, and I'm going to scroll up a little bit until I get to the first face. These faces are 1-indexed. These attributes are 1-indexed, meaning that unlike arrays in everything else in computers besides Lua, the first element, instead of being index 0, is going to be index 1. And that's not something that's hard to deal with, but it's just one of those intermittent pains that come up when you try to deal with importing an OBJ file, because it's easy to forget that and end up with a bunch of off-by-1 errors and you don't know why. In addition to that, it is possible that faces might or might not be formatted like this. For one, it is possible that you might, for example, see a face with 4 elements in it instead of 3. I'll get to that in a little while. It's also possible that you might see a face that is, instead of 3 numbers separated by a slash, just 3 numbers, like this. And if you see this, this is just going to correspond to position information only, no texture coordinates, no normals. It is also possible that you might find either just 2 numbers separated by a slash, or possible that you might find 2 numbers separated by 2 slashes if you're dealing with either only position and texture or only position and normal information instead of all 3. And again, I'll deal with that in a minute. But first, let's jump back into GameMaker, and when we see a face attribute, let me say var v1 is going to be tokens index 1. Come on, index 1. Var v2 is going to be tokens index 2. Var v3 is going to be tokens index 3. We are going to want to split each of these into their constituent parts. So we're going to use split. We're going to use string split for a 3rd time. This time using the / as the delimiter. Let's say v1 tokens equals string split v1. The delimiter. It's a hard word to say out loud. I keep saying delineator, don't I? Anyway, v2 tokens, v3 tokens, like this. Now, all of the faces in this OBJ file that I'm loading right now are what I'm going to call well-behaved, and they don't have any of the silly nonsense that I just complained about a minute ago, so I don't have to deal with that immediately just to get this working in the game. But I do have to still deal with the off-by-1 issues, so I can say, oh, how about var v1 position is going to be v1 tokens index 0. Var v1 texcoord is going to be v1 tokens index 1. Var v1 normal is going to be v1 tokens index 2. These, again, are going to be strings. These are not going to be numbers yet, so to tell GameMaker that I want them to be a number, I'm going to want to go and cast those to a number. And I can do the same thing with v2 and v3. The fact that all of these lines don't line up perfectly annoys me, perhaps more than it should. So we've got our position, our texture coordinate, and our normals for each of the 3 vertices in the triangle, or at least the indices in the positions, normals, and texture coordinates array. Again, off by 1, because these things are 1 indexed. The common way to deal with that would be to subtract 1 from these indices, and then you just say something like positions index this. You can say text coords index that. You can say normals index that. So now we have the actual struct containing the x, y, z, or the x and y for each of these things. And from here, we can start building our vertex buffer. So VB is going to be our vertex buffer. Our position is going to be v1 position dot x dot y dot z. Mind the vertex format that you use to, or like how you created it in the first place. So in my case, again, it's going to be 3D position, 3D normal, 2D texture coordinate, and then a color. And the data has to go in that order. So up next would be vertex normal, v1 normal.x, normal.y, normal.z, vertex texcoord. This just has an x and a y, or if you decided to name them u and v, you can call them that. And lastly, vertex color. As I said, OBJ, like the vanilla OBJ spec, does not contain vertex color information. If you're loading from a material file, you can use the material color as your vertex color. If you are using the unofficial OBJ vertex extension, vertex color extension, you can get the information from that, but I'm not going to do that. That's going to be our first vertex. Our second vertex is going to be much the same thing, but with v2 position. And once I finish this, we should be able to load our OBJ file. And also, how about in the draw event, let us vertex submit. How about chest, or VB underscore chest, I guess, to keep with my consistent naming convention. The primitive type can be a PR triangle list. Where are we there? The texture can be sprite get texture SPR Xenoblade subimage 0. And if I did everything correctly, the game should not crash, and we should have, at the world origin, a tiny, tiny Xenoblade chest, because the scale of this object as it was like authored in the 3D modeling tool is, this is another common problem in 3D. Most people will tell you that 1 unit in the 3D modeling tool should correspond to 1 meter in world space. Because I am coming from GameMaker, I sometimes find it is easier to assume that 1 meter in like the 3D modeling tool equals, or I should say 32 world space units in GameMaker correspond to 1 meter instead. So 1 unit in the 3D modeling tool is going to be 1/32 of a meter, or something to that effect. And you often can get some, let's call it scale mismatches. When you try to import 3D objects, I'm going to just deal with that by setting a matrix transform with no position, no rotation, but a scale of, how about 32, 32, 32 on all axes. And this is going to blow this up a little bit. You might notice there's a couple other problems here. One, it's not standing up, because this is going to be another common refrain you hear in 3D and GameMaker a lot, so if you're new around here, buckle up. There is no common consensus on whether the y-axis should be the up vector in 3D space or the z-axis should be the up vector in 3D space. I personally think the z-vector should be the up vector in 3D space and that everybody who uses y-up is silly, but on the whole, in the computer graphics world, I'm in the minority, and dealing with going between y-up and z-up is something that you'll have to just deal with like all the time. The easiest way to do that, I think, would be to take the the z and the y coordinates when you read vertex data from the file, vertex position data from the file, and just swap them around. So z is going to be the vz part of the coordinate, and z is going to be the vy, and then you'll have to do the same thing when it comes to reading normals out of the file. I don't believe this will also preserve the forward vector, because that's a whole nother thing when it comes to like left and right-handed coordinate systems. Oh, I thought the lighting on that thing looked funny. So y and z, z and y. Anyway, left-handed and right-handed coordinate systems are definitely a story for another day. And you may also notice that the texture on this thing is a little bit, shall we say, not what it's supposed to be. And that is because, say it with me, there is no consensus on whether the 0, 0 point on a texture should be the upper left or the bottom left. So this 3D model file was authored in Blender. Blender thinks... Alright, scroll up to the top, please. Blender thinks that the origin point of a texture file should be the bottom left. I think, and GameMaker thinks, the origin point of a texture should be the top left, going by the same logic of screen coordinates, where like up here is 0, 0 and down here is like 1, 1. The easiest way to deal with that would be to, when you read out the texture coordinates from the file, just to do 1 minus the vertical texture coordinate, so 1 minus the texture y coordinate or the v coordinate or whatever. You can leave the x alone. And now if we run the game, if we look at our treasure chest, alright, that looks, I'd say that looks pretty good. We've got the lighting on the side that it's supposed to be on the front, coming down kind of from the like upper right. All the vertices are in the right place. And if you're, if that's all you need, if your faces are, as I called them before, well-behaved, then you can stop right here. We're about 80-something lines in. I said it would be about 100. I'm still going to write a little bit more so that I can deal with the silliness that can come with face attributes. But for a very basic, very rudimentary OBJ file importer, this is kind of all you really need. However, since OBJ format is a bit of a Wild West, and since face attributes can be formatted in a few different ways, like I mentioned before, I think it would be a good idea to discuss some of those things. And the first thing that we're going to deal with is that faces aren't actually triangles. They are triangle fans. If a triangle fan just has 3 points like this, then it's going to just form a triangle. But if it has a, for example, a 4th point, then, and I'm going to think I'm going to whip out my my drawing tablet for this. The way that the points in a triangle fan will be connected, say you have 4 points in this order, will be your first triangle will connect vertices 1, 2, and 3 like this, and your second triangle, let's pick another color, will connect vertices 1, 3, and 4 like this. This is a fairly common way that you can store a, for example, a square as a single face. And then you could store a square with just 4 points instead of, because you would need 2 triangles. If you stored them separately, you would need 6 points. So it's a little bit more space efficient. If you had a 5th vertex in your triangle fan, let's pick another color. I like red. Let's do red. It would be points 1, 4, and 5. And you could continue that way with however many vertices you want in your triangle fan. If you want like I don't know, an octagon, you could have 8 of them. I guess 9 because you would need 1 for the center. Anyway, faces in OBJ files are triangle fans, and the way that we would do that would be instead of hard coding the 3 vertices for its triangle as indices 1, 2, and 3 in the line. In the tokens array, we could loop over, let's say var j equals 1, j is less than array length, tokens array j++. You could loop over the remainder of the tokens array. Almost everything else would stay the same here, but actually instead of j equals 1, I'm actually going to want to start j at 2 here because tokens index 0 is going to be the letter F, right? That's the first thing in the line. Don't forget about that. Tokens index 1 is actually going to be v1 at all times. Going back to the Sandy diagram, in each of these triangles, they start at vertex 1 down there. v2 is going to be j minus 1, and v3 is going to be j. And this will allow us to loop over vertex 3, vertex 4, vertex 5. Did not label that one. And it will allow us to construct a triangle starting with the initial point j minus 1, whatever that happens to be, and then lastly point j, which is the loop counter. We don't have to change anything else. If I run this, nothing is actually going to visibly change in the game, but this is something that I decided not to do in that original OBJ loading video all those years ago, and it is probably the most common problem people have had with it. If they like make a cube or something in Blender which hasn't been triangulated, and then they're suddenly missing like half of a quad or 2/3 of a pentagon or something like that. That's not too bad. That's you just have to make sure to read these out in a triangle fan. Now the part that is actually a little bit more irritating, and for what it's worth, I don't think this is very common. I think Blender, for example, will pretty much always write all 3 of these attributes, the position, the texture coordinate, and the normal, to the file, but because that is not guaranteed, it may be a good idea to write a little bit of code to guard against those other cases. Probably the easiest way to do that, and I've written this in a few different ways over the years, but probably the easiest way to do that would be to say switch, how do you spell that? String count, the number of slashes in v1 tokens, and we can say if there are 0 slashes, we can do one thing. If there are 1 slashes or 1 slash, we can do another thing. If there are 2 slashes, then that would be the case where we do what we were doing. You could also say, you know, instead of string count, you can also just say array length. And then it would be 1, 2, and 3. Alright, that would be the sensible way to do this. I don't know what came over me a minute ago. Anyway, as I said, if there is... if you only have a position, you could leave position alone. You could say texture coordinate is going to be just some null value, because you do need to write a texture coordinate to the vertex buffer. If your vertex format calls for it, you can't just ignore it. So I'm just going to set that to 0, 0, and for the normal, we're going to do something pretty similar. I can set the normal to 0, 0. If you have just 2 terms in this, then that means you have a position and a texture coordinate. You can again set the normal to 0, 0, some null value. And if you have 3 terms, it is possible that the middle term, so v1 tokens index 1, could be an empty string. And if that is the case, you're still going to need to accommodate for like not having a texture coordinate like this. So you're going to want to set that to the null value, and you can just read the normal index as you were before. And all right, so this is actually going a little over 100 lines. It's not quite going to be as compact as I thought it was going to be. We can do this for the other two vertices in here as well. I'm going to go ahead and write this on my own because I think you don't need to see me writing that out the long way 2 more times, because this is kind of tedious and kind of annoying and kind of a pain. Alright, that looks like what it's supposed to. If you run the game now, the OBJ importer will now accommodate for all of the different face attribute formats that you might find in an OBJ file. You might notice that we've got all of these squiggly yellow lines in here because Feather doesn't really like it when you don't declare a variable in a scope that it's used in. This is also a little bit verbose. We are down to 130, 140 lines. This can actually be compactified just a little bit. If you wanted to declare the null values that aren't being used outside of these switch statements, and then just reassigning them if the need arises. We'll also just declare that variable there so Feather shuts up. We can reformat that so that it's just a little bit more a little bit more neat and tidy. Like this. It feels a little bit weird to write code like I just did and then like immediately unwrite it, but I don't know. I thought it would have been weird to write it like this way the first time without like stopping to explain why I changed it. Anyway, everything should still work here, unless I made any silly mistakes, but it looks like that everything is still in working order. This will take care of any funny formats that you might find in a common OBJ file, and you can call it a day. Now, let's see, we clocked in at 137 lines in total. Before I end this off, I do want to make a point about, I did say that you probably don't want to do this in an actual game because parsing plain text is slow. To illustrate that, let me say var t start equals get timer. I'm going to do that after I load the buffer, by the way. After I vertex freeze, or really after before I vertex freeze, for reasons that I'll explain in a minute, I'm going to t end is going to be get timer again, and then we can show debug methods parsing the OBJ file took t end minus t start divided by 1,000 because this function returns the current time in microseconds. We can just throw a little timing around this code, and we can see how long this takes. So this loads up pretty fast because this is just one file, and it's not that big. But if I were to look at the timing, and where would this have gone in the console? Here we go. If I look at the timing, parsing this OBJ file took 87 milliseconds. On its own, this isn't a lot, and it's easy to say that this would fall into that micro-optimization territory that I'm constantly railing against, but this is just one OBJ file, and it's taking the equivalent of 5 frames to load. And it's only got, I want to say, about 100 vertices in it, maybe 200 vertices. If you have a large file for, I don't know, for example, terrain or for a building with thousands and thousands of vertices, or if you have 50 different treasure chest models, it can very easily take multiple seconds or even multiple minutes to just load all that into your game from OBJ files. So this is really not something you want to do. What you really want to do in your game is take the OBJ, pre-compile this ahead of time and save it as like a vertex buffer that you can just load into your game as a buffer and use a function like vertex create buffer from buffer to just convert it straight into a vertex buffer without having to do all this. That will be much faster. And like by taking, when I say this takes a long time, this isn't even anything that has to do with like your hard drive speed. It doesn't matter if you have a fast SSD or not, because the time that it takes to do this isn't actually dependent on how fast your SSD is or whatever. That's going to be up here in buffer load when you call buffer load. This is just all the time that GameMaker actually spends like looping over the contents of the file. And if you ran this in YYC mode, it's going to be a little bit better. All right, the game has started. We're running in YYC mode. That took, oh really? It wasn't even that much better. Still 63 milliseconds. But still not something you want to do every time your game starts. It's also worth just tossing a mention to the fact that this is not 100% optimal code for loading an OBJ file. It's definitely probably still better than a lot of the older OBJ parsers out there, because we don't have to any longer do things like split strings ourselves, because GameMaker will do that for us. Being able to take care of like positions and whatnot using just a struct like this definitely helps. Array push in GameMaker is slow. It's really annoying. You could use, instead of an array, you could use a DS list, which is faster to append to. You would, of course, then have to remember to delete them when you're finished with it. You could squeeze some more performance out of this by doing things like caching values that are referenced more than once, instead of having to constantly allocate new structs like this. I'm not going to get into that today. You can take it as a personal challenge to see how you can optimize this OBJ parsing function here in different ways if you'd like. In fact, that might be fun. If you're really into micro-optimizing your code, tell me how much you can squeeze out of it in the comments. That'll be your homework. But anyway, let's see, some honorable mentions for when you have written your first OBJ parser and then decide that you don't want to do it yourself. Juju Adams got a nice little project called .obj, which will do this for you, and it will also take care of things like materials and some other nonsense. You may be interested in that. I have what I like to refer to as my 3D file Swiss Army knife, which I like to call Penguin, which will automatically take an OBJ file or some other 3D file formats and let you convert them into GameMaker vertex buffers, as well as doing some other things like transforming them and correcting the up vector and stuff like that. I personally like it. I have a fun time working on it, and if you want to use it, I will have a link to this down in the video description. Otherwise, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down below. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. And if you felt like pledging, I definitely would appreciate it. You should all go check out Wizarducks, which is the game that I like to work on in my own time when I'm not doing YouTube stuff. Link to the store page can be found down in the description of the video as well. I hope you all find this useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.